right, yesterday was September 24th. It was Monday, and what we did in our notebooks, we put this on page 40. Move it over here, 40 and 41, and what I did is I folded the periodic table of elements and just put it against these two pages in my notebook, 40 and 41, so we have a full page of the periodic table. So I'm going to back off here so you can kind of see this a little bit. Try to anyway. What we did is we coded the periodic table with a couple things. We talked about it, and then we did a using the periodic table worksheet for a grade. We did several together in class, and then we worked on it on our own. So that's in the orange folder back there. It was the using the periodic table. But what I did is I put the families, made sure I put the families on each one. So 1 and 2, you can see families 1 and 2. And then we went over here and did 13 through 18. So we coded those as our families, we circled those. And then the next thing we talked about was the valence electron. So one other thing I did for you is that I wrote in here what their valence number is, so how many valence electrons that they have. Everything in family 1 has 1 valence electron. Family group 2 has 2 valence electrons. Then we're going to come over here. In the transition metals, those are going to end up changing, so these can change, so we're not going to put valence electrons there. But when you pick up with these upper level ones, you have family group 13 has 3 valence electrons, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and 18 has 8. So remember, our octet rule states that elements want to have 8 electrons. So these guys right here are called our noble gases. They have 8 valence electrons, meaning they're stable and they will not react. Then we talked about how others would bond to get 8. So if I look here, this family 17 has 7 valence electrons. So they only need 1 more to be stable. So a lot of times you'll see that family group 17 with 7 valence electrons will bond with family group 1. So elements from family group 1, because they have 1 valence electron. And family group 1 and family group 17, with 7 valence are going to give us a total of 8, and that's what they're looking for. So if you're in family group 16, they have 6 valence electrons, and a lot of times they will bond with elements from family group 2, because family group 2 has 2 valence electrons. If you're in family group 3, you will most likely, a lot of times, bond with family group 5, and so on and so forth. 4 usually bonds within itself or covalently, right there. So we're going to leave that as that. So those were the valence electrons. The next thing we did is we talked about periods. So the periods, remember, are going across. So there are 7 periods on the periodic table. Even the ones that are dropped down underneath, this is part of period 6, this is part of period 7. So I did that, and then I even wrote a note at the bottom of your copy that the family groups go up and down or vertical, and they tell the number of valence electrons. Then your periods go across and they tell the number of energy levels. So if I'm in period 3, in this row this way, sodium all the way to argon, if I'm in there, I have 3 energy levels. If I'm in period 4, I have 4 energy levels, and so on and so forth. So those are the basic main things about the structure of the periodic table. Then we went through and we left metals white right here, and then I shaded my non-metals as yellow. So all I did was I colored the symbol. So hydrogen is a non-metal, and then I'll let you pause over here to get those. All these yellow ones: helium, carbon to neon, phosphorus to argon, selenium to krypton, iodine, xenon, and radon. Those are all your non-metals over here on this side of the periodic table. Then I did metalloids in green. You can choose your own color and color in your square, but your metalloids are right here. Those green ones are your metalloids. Then we looked at solids, liquids, and gases at room temperature. So if we change the temperature, of course these things can change states, but I just wanted you to see how many of the periodic table, or how many elements are solids. The majority are solids. I put a little S in the upper corner of all the solids. And notice we left a lot of those blank or white, and those are all metals. Those are all solid metals. So there are 2 liquids on the periodic table, and the 2 liquids are mercury, and so we highlighted that in, I did it in blue, and bromine at room temperature. So if I had mercury and I dropped the temperature down to make it a solid, it would still be mercury, just in a solid form. But at room temperature is about 70 degrees Fahrenheit, around 20 degrees Celsius. Mercury is going to be a liquid, and so will bromine. Everything else that says S will be a solid. Now I did my gases in pink. So the gases have a little G in the upper corner. So hydrogen is the only nonmetal gas on this side of the periodic table. It's there because it has 1 valence electron. Over here you can see that your gases are in pink with the G's. So I've got all these are noble gases, of course. They're stable, they're not going to react, and they're all gases because they're noble gases. Fluorine and chlorine, oxygen and nitrogen. So those are the gases. Now down here I've got an X in the corner of 93 through 103 because these are synthetic. So synthetic means that they're man-made, their properties aren't very well established, or they're under different pressures and temperatures at different times, so they can be manufactured and made to be at any state just with the changes in temperature and pressure. So they don't really exist necessarily at room temperature because they don't exist naturally. Okay, so that's your basic there. And then we did the using the periodic table worksheet, and it is just a bunch of clues that you use your periodic table to find things. It's more like a scavenger hunt than a worksheet, but it is in the back in the orange crate. So we're going to stop there.